On the lower right-hand side of your notes, I'd like you to write the title biconditional. And again, you'll be writing in the definition after I show you an example. Now, to know what a biconditional is, you need to know what the conditional and converse are for a certain statement. So we're going to start first with the conditional. The conditional here is, if a polygon has 3 sides, then it is a triangle. There it is. If a polygon has 3 sides, then it is a triangle. Now remember, the converse is when you rearrange the statement so that the conclusion and hypothesis have switched spots. So I'm going to move them around to write the converse. But remember, I'm going to use English to make sure my sentence makes sense. So I'll start, if a polygon is a triangle, okay, so I've moved the conclusion over, then it has 3 sides. Now with our previous example, when I taught you about what a converse was, we checked to see if the converse was true. And I'd like you to do that here too. We're going to use that same picture. I'm going to move Slinky over here. We're going to use that same model as we did before, and we're just going to focus our attention on the converse. So here's our hypothesis. If it's a triangle, how many sides does it have? Now this hypothesis says it should have 3 sides. The conclusion says it should have 3 sides. Okay, so if a polygon is a triangle, the only option is it must have 3 sides. Let's think. Can you think of a counterexample? Is there a triangle that doesn't have 3 sides? I can't think of one. Can you? That means the conditional's true and the converse is true. In that case, if both the conditional and the converse are true, then it can be rewritten as a polygon is a triangle if and only if it has 3 sides. That's combining the conditional and the converse into one sentence that works this way and this way. So if a polygon's a triangle, it has 3 sides, and if it has 3 sides, then it's a triangle. And you can only write a biconditional like this if you've tested to see if the conditional and the converse are both true. And that's what a biconditional is. Go ahead and take a moment and write in your biconditional definition.